All right, everyone, welcome back to another one of Mr. Martin's math videos here for BC Math 9. We're looking at Chapter 4, Section 3, multiplying and dividing polynomials. So last lesson was all about adding and specifically even more challenging subtracting polynomials. Today we're going to be looking at multiplying these polynomials and dividing them. So by the end of the lesson, you should be able to use multiple strategies to multiply and divide polynomials, and also solve problems involving multiplication and division of polynomials. So be able to use the math skills that you have in different ways. Okay, so we're going to be doing it algebraically and also using algebra tiles. And also be able to apply those skills in new situations like word problems. Yes, word problems. So make sure that you fully understand the math behind it so that you can apply it in new scenarios. So today's lesson, we're going to be learning to combine polynomials in new ways. Last class, we learned how to add and subtract polynomials. This class, we'll be learning how to multiply and divide. All right. Just as a reminder for some of the blocks using algebra tiles, those long rectangular blocks that are shaded in or green are positive x. A solid square, small square, is positive 1. And a solid or shaded in large square is x squared. Okay, and the negative is the same shapes but not shaded in, and you'll see. We'll review as we face the questions here, but that's how we're going to be using algebra tiles. All right, but first we're going to look at algebra. Okay, algebraically, how do you multiply each of these? So the trick for these, so our first one that we're doing is 3x times 2x. Okay, now one thing which you want to do when you're multiplying polynomials is you want to just split up your terms into individual symbols, right? And so here, instead of writing 3, well, I'll just write it without brackets, right? This is 3x times 2x, right? So far, so good. And we know that because the 3 is next to the variable x, with no sign in between, we assume that it's a multiplication between the 3 and the x. And because the 2 is right next to the x, again, we assume that it's multiplication between the 2 and the x. So what we end up with here, if you guys see, is 3 times x times 2 times x. Okay? And that's a better way of looking at it. Okay? And now we try to multiply the numbers or variables together that we can. Okay, so if a variable is multiplied by itself, we can do that, and we can multiply numbers by itself. So we can do 2 times 3, right? We know that 2 times 3 is equal to 6. Okay, so I've taken those two coefficients, multiplied them together to get 6, and then x times x, if you guys remember your exponent rules, x times x is x squared, right? You do x times x, you get x squared. So that's all you have to do here. You have to see it not as 3x times 2x, it's 3 times x times 2 times x. And then you can multiply the 2 and the 3 together to get 6, and the x and another x together to get x squared, and you're done. You have your final answer. It's just that easy. Let's see if we can visualize this in a different way using algebra tiles. So here, algebra tiles, I'm going to set up my grid for my algebra tiles. 3x on the top, I'll do 3x. Okay, so 1x, 2x, 3x. Okay, and so these will be shaded in. So I'm going to use the shortcut here to shade in my tiles. Okay. And then on the left side here, we're going to do 2x. Okay, so 1x, 2x. Okay, and I can shade those in as well. Okay, so see that they are positive x. Okay, now if you remember for algebra tiles, we take the width of the top row piece tile and the length of the side row tile. So the width of my top row tile is this wide, and the length is this far down, and then I complete the shape, and I end up with one large square. And because it's positive x times positive x, it will be shaded in. Okay, and that's going to be the case for all of these where they interact, right? I take the top tile again and multiply it to the bottom tile on the left side, and I get, again, the width of the top tile, the length of the side tile. I complete my shape, the width of the top tile, the length of the side tile, the width of the top tile, the length of the side tile, and then I fill in the rest. Again, the width of the top tile, the length of the side tile. And this is what I end up with. Okay, just let me finish the coloring here. All right, so what do I end up here with? Okay, what is a large square shaded tile represent in algebra tile? Well, if you guys remember our short little review here, it represents x squared. Okay, so each one of these, okay, is x squared. And how many x squareds do I have? I have 6x squared, and hopefully you recognize that answer because it is exactly the answer that we got using our algebraic method. Okay, so that's a way to visualize multiplying various monomials, and that's how you do it with algebra tiles. Okay, you do have to know how to do both. Okay, there will be test questions, not just on the algebraic way of doing it, but the algebra tiles as well. You just got to know how to do it, but make sure you understand and can do both. All right, let's try another one. Here we have a negative, oh my, but it's the same idea, right? See this as 3x times 2x, and I can, kind of visualize this. It's not just 3x times, oh, sorry, this is a negative 2x. It's 3 times x times negative 2 times x, right? And so that's just multiplied. I could rewrite it maybe if this will help you see it even more. It's 3 times x times negative 2 times x, right? That is what we're saying here when we're multiplying these monomials together. And so I can take the coefficients, the two numbers, not the non-variables, I can take and multiply together. 3 times negative 2 is negative 6. All right. And then the two variables I can multiply together, especially if it's the same variable multiplied by itself. X times x gives me x squared. All right. So that's our answer here. And algebra tiles, we'll go through this again. Here I have the 3x tiles on the top. Okay, and I have two negative x tiles on the side, right? This is negative 2x, this is positive 3x. Okay, this is a separate question, right? Or a separate way of doing it in the same question. These are positive 3x, so they have to be shaded. All right, again, width of the top piece, length of the side piece, complete your square or your shape, and you end up with 6 tiles again, large square tiles. Now, I'll ask you a question as I'm drawing this. Do you think I have to shade these tiles or no? Hopefully you're able to determine that no, I shouldn't be shading these tiles because I'm multiplying negative tiles by a positive tiles, and when you multiply a negative and a positive, you always end up with a negative. So here I have each of these tiles represent not positive x squared, but negative x squared, and I have 6 of them, so that gives me negative 6x squared as my final answer, just like I got at the top there, algebraically. Good. Hopefully that made sense. If you need to pause and re-watch, go ahead and do so. We'll look at one more example, and then you'll get a chance to test these skills out for yourself. Okay. So algebraically, again, I'm looking at this. I know that it's not 3x times 2x. Well, it is, but I can represent it as 3 times x times 2 times y. Okay, the 3 and the 2 are still able to multiply to each other. And so this gives me 6. Okay, now in this situation, x times y doesn't give you x squared or y squared. It just gives you xy, right? You can't multiply that. Like, you can't get rid of them, and you can't use an exponent or anything to simplify that any further. So that would be our answer here, 6xy. All right. Using algebra tiles, we'll try to represent that again. Here, setting up my grid. I have 3x. Again, I'm going to put it along the top. 3x positive, right? All right. And here, we're not drawing an x tile. We're drawing a y tile, 2 y tiles down the side. Okay? So the way that you draw different tiles, you can do it in different ways. You can shade them with a different color if you'd like. But the best way that I recommend that you do is you draw them a different size triangle. Okay, still a triangle, but a different size. So I'm going to have these short little triangles here. Okay, and they are positive as well, but they're different shape. They're not quite X tiles, they're Y tiles. All right, so now again, I'm going through drawing my the solution with these tiles, and so I take the width of the X tile and the length of the Y tile, and I end up with this kind of different shaped tile. It's not an X squared tile because it's not a square. It's a rectangle with the width of an X tile and the length of a Y tile. Okay, and of course, because it's positive times positive, all of these will be positive. So what do I call a tile like this? It's not an X squared tile. It's not a Y squared tile. It is a, well, we call these tiles here, these are XY tiles, okay? These are all XY tiles because they are not squares, and so you can't call them either X squared or Y squared because they're not squares. So they have a width of X, a length of Y. We know that the area of a rectangle is length times width, so X times Y, which gives you XY. And we have 6 of them, so we end up with 6xy, which is the answer that we got when we solved it algebraically. All right, give this a shot. It's your turn. You got 3 different examples. I want you guys to show your algebra tiles for at least the first one. Okay, B and C, you can do it just algebraically if you like, but for A, you need to show both the algebraic and the algebra tiles as well. All right, so go ahead and pause the video, work on that. Try, fail, try again, and then when you're ready to see me go through them, unpause the video and we'll continue together. All right, hopefully that went well. Hopefully you were able to apply what we just learned in these new problems. All right, I'm going to go through these now. So 4x times 2x. Again, I know that this is 4 times x, and then times 2 times x, okay, and now I can just take my coefficients, multiply them together, which gives me 4 times 2 is 8, and then x times x, because they're the same variable, I can simplify them with an exponent, which would be 8x squared. Okay, that would be your final answer. Okay, for algebra tiles, let me put a line here just so that I don't bleed into the previous space. X and the length on the top and the side. Okay, on the top I'm going to put my 4x positive x tiles. Okay, this is going to be lots of drawing here. Okay, and then my 2x tiles down the side. Notice that because they're all x tiles, I'm trying to draw them all the same length. Now, you know, it's not perfect. okay, but I'm trying to draw them all with the same length, okay, because they have a length of x, both the tiles on the top and the tiles on the side, okay, so that when I bring the tiles together, when I multiply the tiles together, I get a square that has a width that is as great as its length, okay, at every position. Width of the top tile, length of the side tile, and complete my shape. Yeah, algebra tiles, sometimes a little bit tedious. They can help us understand concepts and visualize concepts in a different way, but they are a tool that is meant to be outgrown as we go, okay? And you can kind of see why once you understand the algebra and what's going on by visualizing them with algebra tiles, you don't need the algebra tiles moving forward, okay? So they're kind of a teaching tool that we use. It's a teaching tool you have to know. They will be on the tests, but it's something that I also want each of you to outgrow, okay? And so here, each of these tiles is an x squared tile, right? Because they have a length of x and a width of x. And I have 8 of them, so that's 8x squared. Good? Just like I got when I solved the problem algebraically. These two, I'm just going to do algebraically. I don't want to do the tiles anymore. You can go and watch me do tiles just by starting the video over if you'd like, but I'm done with tiles for now. So let's take a look here. This is -3 times x times 5 times x. And so I can multiply my coefficients here. That gives me -15, and my variables, which gives me x times x is x squared. Okay. By now, you probably can also are not even doing this step anymore, right? Because you're seeing that you're taking your coefficients, which is the numbers in front of the variables, multiplying those together because you can, right? We know how to multiply numbers together. And then we're taking the variables and multiplying them together, okay? So that's what we're doing. So in C, I'm just gonna go straight from the question to the answer. So I have my coefficients, 5 and 4, multiplied together, give me 20. And then my variables are x or y and x. And so y times x is xy. I do put them in alphabetical order so that they're in alphabetical order. It's just best practices, and it will be helpful in the future when identifying like terms. It's helpful that your variables are in alphabetical order. And yeah. All right, so those are your answers. Hopefully you got them all right. If not, make sure you understand where you went wrong. All right. Next, we're going to be looking at dividing monomials, okay? A quick tip when dividing monomials, think about this question. If I have x divided by x, what does this equal to? X divided by x, of course, equals 1, right? Any number divided by itself is equal to 1, and that's a really important principle when we're dividing monomials, okay? So let's give this a try. Let's give this a shot algebraically. Now, when you're doing these things algebraically, you want to break it down and you want to write them as a fraction. It's just a helpful visualization, at least for me. So 8, and then here, instead of writing x squared, I'm going to write it in expanded form. So 8x and then times x, okay? And then divided by 4 x. Okay? So I've taken the variable and I've drawn that variable out in expanded form instead of exponential or in a power form, and I've written the two monomials one above the other. Okay? Now, just like I was doing before, the coefficients, I can divide. 8 divided by 4 is 2, right? You should have that in your mind. So 8 divided by 4, you can double check in your calculator if you absolutely need to. 8 divided by 4, 2. All right, good. I'm not going crazy. 2. Now, I can move here and I can do x divided by x, the next two variables here. X divided by x, I just said, was equal to 1, right? And so x divided by x is equal to 1. So here I can write it out, right? Like, oh, it's equal to 1. But what is 2 times 1? The answer is 2, right? When you multiply a number by 1, it doesn't change the number. It stays, in this case, 2. So essentially what happens then is the x's cancel out because they equal to 1, and 1 is not going to change the value of the 2. It stays 2. So the x's cancel each other out because of that. And what we're left with is an x divided by nothing, and so we're left with 2x. And that would be your final answer. Okay? Now, algebra tiles for this is a little bit trickier, okay? Because here, you're trying to find one of the two products that gave you the 8x squared. So 8x squared, you have to draw inside of your grid, not on the top or on the left side. It goes inside your grid. All right. And of course, we have to shade them in. Lovely tiles. Okay, there's one. Sorry, my tiles are getting worse and worse because I'm getting less and less patience. And the longer these videos go, the longer they take to upload to YouTube. All right. And then 4x I draw on one of the sides. I want it to kind of match, so I drew them. Notice that, I guess I didn't explain this, but notice that the 8 tiles, I drew them in 2 rows of 4 because I want my 8 tiles to be lined up below my 4x tiles. Okay? Because each of those 8 tiles got their width from the x tiles on the top, the 4x tiles. Okay? So they all have to line up. And here, when you're drawing tiles inside of the grid, not on the outside here, they have to. You want to put them in rectangular shape. Okay, in a rectangular shape. A rectangular shape that matches one of the sides. Okay, in this sense, this situation, I have 4x. I'm trying to figure out what this side is going to be. Okay, so each of these tiles got their width from the 4x tiles on the top, and they got their length from the tiles on the left side. Okay, and we can see here that their length is the length of a full x tile. Right? That's the only tile that could give them a length of these, for these squares, these x squared tiles, these 8x squared tiles. And because the 8x squared tiles is positive and the 4x is positive, I know that my tiles on the side here are positive as well. And I have 2 of these x tiles, which gives me 2x as my answer. Okay, so that's how you divide monomials using algebra tiles. Again, it's just a visualization. Algebraically is how you're going to be doing it moving forward, but it is helpful to kind of visualize that. Let's try another one. Here they've already written it out like as I like to see. Okay, so I'm going to go straight from here. I have my coefficients, -4 divided by 2, 4 divided by 2 is 2, and negative divided by a positive is negative, so that's going to give me -2. Now if you're, negatives and positives are still giving you a hard time, well, you got to figure that out, right? You got to learn that properly, but you also have your calculator to double check, so here it would be equal to -2. And then here, I'm trying to cancel out 2 variables that I can make equal to 1, okay? If I do the x divided by the y, that doesn't equal 1, so that's not helpful, so I'm not going to do that. Instead, I'm going to divide the y by the y. And why do I divide the y by the y? Because y divided by y is equal to 1. All right, that's why. Okay, so they cancel out, and I end up with -2x, okay? So that's my answer algebraically. You can go in this space or you can leave it there. Algebra tiles, yippee. I have, I'm going to draw my The number that's being divided is one that goes inside the space. So I have 4 xy tiles. Now remember, for xy tiles up here, my xy tiles, I have to make sure that their width and length are not the same, okay? Because if they had the same width and length, then that would be an x squared, because it's a square. I need an xy triangle, rectangle, not triangle. So that I have to kind of intentionally draw that, okay? So I'm going to put 1. Okay, notice that my width and my lengths are noticeably different, and I'm going to line them up in a rectangle kind of shape. Okay, because I know that one of my sides here is 2y. Okay, that's why I wanted to line them up in that square rectangular shape here. Okay, now these are these are negative. The 2y's are positive, so I'm gonna shade those in. Okay, now what would I get on the top here? Would be 2 x tiles, x length tiles. Okay, and because my inside tiles here are negative xy tiles, these 2 tiles are also negative, so I don't shade them in, and I have 2 of them, so that gives me negative 2x, and that is my answer, and that was my answer when I did it algebraically. All right, so that's that algebra tile visualization. Okay, it's your turn. Again, I want you guys to do at least one with the algebra tiles, and then you can go to the numbers say 3, 4. So we've lost number 2, but you do one with algebraically and algebra tiles, and then do 3 and 4 using the method of your choice. I strongly recommend that method to be algebraically, because that's the method I want you guys to be comfortable with in the end. All right, so go ahead and pause the video and unpause when you think you got them all right. All right, I hope that went well for you. We're going to go through these here. I have 6x, and I'm going to expand the 6x squared into 6xx, and then divided by negative 2x. Okay, I got some coefficients here I can divide. 6 divided by negative 2 is equal to negative 3. And then x divided by x is equal to 1, which essentially cancels them out, which leaves me with negative 3x as my final. The reason, so that last x there, that can't be canceled out, this one here gets brought into the answer there. All right, since it's not canceled out, it stays. All right, so that's what ends up here. Okay, algebra tiles, so that's our answer. Algebra tiles here. Again, I'm going to line up my 6x tiles. I know that I have 2x tiles, 2 negative x tiles on this side, so I'm going to line up my 6x tiles so that left to right they all have the length of that those negative 2x tiles, okay? But those 6x tiles are positive, so I need to shade these in again. All right, shade, shade, shade. Okay. Now, based on their arrangement here, I can see that on the top here, they've got their width from 3x tiles, okay? And because they're positive, and this is 2 negative x tiles, okay, given to me from that there, okay, negative 2x. I know that I have to have negative 3x tiles to give me positive 6x squared tiles, because negative times negative is the only thing that would give me a positive in that situation, okay? So that would give me that answer, okay, which is the same as what we got algebraically. Let's step it up here for algebraically. 10 divided by 5 is equal to 2. Y divided by y is equal to 1, so they cancel out. And then all I'm left with is that x to bring over. And that's your final answer. And then again here, negative 12 divided by negative 3. Negative divided by negative is going to give me a positive. 12 divided by 3 gives me 4. And x divided by x is going to cancel out, which leaves me with a y positive 4y is your final answer there. Hopefully that went well for you. All right, last question, word problem. Everybody loves a good word problem. This word problem has hockey pucks, a good Canadian word problem. So we know we're in for a treat. All right, let's take a look. Hockey pucks are often packaged by stacking them in boxes shaped as square-based prisms. Okay, so here is an example of one of these boxes full of hockey pucks. The volume of one puck is given as this equation here, pi r squared h. Okay, so that's essentially just taking the surface area of the hockey puck, the top and bottom of the hockey puck, and multiplying it by the height of the side of the hockey puck, where r is the radius of the puck and h is its height. The volume of the box is given as 4r squared hn, where n is the number of pucks it can hold. All right, so so here they're kind of arranging these equations together here. So first they ask us, what does 4r squared hn equal, and what does it represent? So first thing, I need to simplify this by dividing these two monomials. Okay, so I don't have any coefficients on the denominator, but I do have two h's that I can cancel out and two n's. Okay, I can cancel them out because h divided by h is 1, and n divided by n is also equal to 1. And so that gives me an answer of 4r squared. Okay, and what does that represent? It represents the area of the top or bottom of the box, because here we have the height with the total number of pucks, and so we're left with the area of the top and or bottom of the box. All right, now let's look at B. What does pi r squared h divided by 4r squared hn equal? So we want to simplify it again by dividing these two monomials. And what does it represent? All right, let's take a look here. Okay, the first thing I want to do, because I have r squared, what is r squared divided by r squared? You guessed it, it's equal to 1. So we can cancel them out. And I have h divided by h again, which I just left to cancel out. And I'm left with my answer, which is 4 pi in the numerator position and just pi in the numerator position and 4n in the denominator position. Okay, and what does that represent? That represents the fraction of the box's volume that is taken up by each puck. Okay, when you take the volume of a single puck and divide it by the volume of the entire box, you get the fraction of the box that is taken up by one puck. Okay. The other one here, what does it represent to write out the answer, is the area of top or bottom of box. Okay, that's what it represents. Okay. Your turn. Question here for you guys to try in coming up with a diagram and then answering the questions, this word problem for you guys. So I'm going to pause the video, give it a shot. When you think you got it right, unpause the video and we'll go through it together. All right, hopefully that went well for you. Let's tackle this one together, shall we? So the area of a rectangle is given by the expression 15x squared. The width of the rectangle is represented by 3x. Okay, so let's start with a diagram. I have a rectangle that has an area of 15x squared and it has a width of 3x. Okay, my diagram is not drawn to scale, but that's okay. Width of 3x, and I want to know what is the length of the rectangle in terms of x. All right. Okay, well here we know that the surface area of a rectangle is equal to length times width. Here I have 15x squared is equal to, I don't know what my length is, but my width is 3x. Okay, so if I want to solve for length, I need to divide both sides by 3x. Okay, that cancels out here. So this ends up being my equation right here. All right, 15x squared divided by 3x is equal to L. Okay, maybe I should erase everything. I'll rewrite it just so that you can see the work. So 15x squared divided by 3x is going to give me the length of the box. Okay, and again, I can rewrite this as, oh no, I don't have to rewrite this. So 15 divided by 3 is going to give me 5. Okay, here for the exponents, I can write an expanded form, x times x, or I can remember here my exponent rules where it's x squared divided by x to the 1. I subtract the exponents, and so x to the 2 minus 1 would just give me x to the 1, and that would be equal to my length. Okay, so hopefully that's what you got for A. Now B, if the value of x is equal to 2 centimeters, what is the total area of the rectangle? All right, so here they've given us the key to this problem. They're saying that x is equal to 2 centimeters. X is equal to 2 centimeters. Okay, so now what I have to do is I have to plug in with a 2 where there was an x before. So if my surface area, my total area, was 15x squared, I'm going to substitute a 2 in the place of 15. In the place of x. So 15 times, and I substitute always with brackets, 2 squared, all right, which is equal to 2 squared is 4. 4 times 15 is 60 centimeters squared. Okay, you can double check in your calculator as well. You have 15 bracket 2 exponent 2, I get 60. All right, and that would be your final answer. Don't forget to square your units as well. Surface area, you need that squared. All right, that's it for these notes. Hopefully by the end of this lesson, you should be able to use multiple strategies to multiply and divide polynomials and solve various problems, word problems specifically, involving multiplication and division of polynomials. At the bottom here, we have our homework assignment, and you'll be able to upload that directly into the Teams if you're in my class. And I hope this video was helpful, and stay tuned for the next Mr. Martin Math video.